All right, we're about to get started. Y'all can hear me through the speakers. We're going to make sure she's all set up, though. While she's getting set up, I'll read this. I'm supposed to read this. As a SANS instructor, we always have our morning notes, so let me read this. This session has been pre-qualified to support continuing education requirements for several cybersecurity certifications. If you are an AFCEA member seeking attendance documentation, please be sure to scan your badge at the scanner located in the back of the seating area at the conclusion of this session. Scanners shut off 15 minutes post-session, so please get your badge scanned before networking with me or any other session attendees. Also note that qualifying for CEUs or CPEs, the session must run the full 60 minutes. That 60 minutes can include question and answers, so please have questions ready so that we can fill the time requirement. Full details on the continuing education program are available in the conference app on the conference website. So I don't think we're going to have a problem going to 60 minutes. I've got plenty of slides, but somebody came in and scanned their badge earlier, and my understanding is that you have to scan it after the session's over. So please be sure as you're going out, if you need your CPEs, please to do that. Excellent. Welcome, everybody. We are going to go ahead and get started. My name's Don C. Weber, and I'm going to be presenting Attacking and Defending Mission Critical ICS Assets. Now, I am one of the instructors for the ICS 410 class, which is the ICS and SCADA Security Essentials. I am also an instructor and an author for the new class, which is the SANS ICS 613, which is ICS and OT penetration testing and assessments. This is finally coming to fruition after a couple years with issues from vendors and COVID not helping us at all. But we are going, we've finally done our 2 alphas, and we're going beta next week in Salt Lake with a full class. Our first teach is going to be in Washington, D.C. at CDI. There's seats available. We'll have links, of course, slides at the end. So let's go ahead and get started. I want to make sure that we get through everything that we want to talk. Now, I am a SANS instructor, so I am used to walking around, so they've got me behind a podium. We have to make sure it's getting recorded, but we'll make it work. Once again, my name's Don C. Weber. I was in the Marine Corps from 91 to 99, got out as a sergeant. I was with the 1st Force Reconnaissance Company when I got out. I was a grunt, 0311, up until I went to college, and then I got my degree in computer science. As soon as I knew I wanted to be in the cybersecurity team, fortunately, I got a job at Raytheon when they were spinning up their stuff, and I started my SANS journey. I started my cybersecurity journey with Raytheon. They got my master's degree. About 2010, I got into this industry because the utility grid in the United States, they were starting to research cybersecurity. Obviously, NERC-CIP was coming out, and they got together with some smart grid working groups, as they called them back in the day, and I did a lot of the hardware research on smart meters, pulling them apart, learning how the components work, learning how they spoke on radios, and helping them to understand how people were going to take advantage of these systems, these public-facing systems, to attack the utility. Utilities were not worried about people stealing electricity. I mean, one of the things that I was told at the very beginning is, Don, we can tell who's stealing electricity and how much they stole. They didn't care about that. They were worried about how threat actors were going to take advantage of those remote systems to get into the utilities and take advantage of their systems within their OT network, so to speak. Once again, I do teach the other classes, so I go around the world, and I also teach out at, I don't know if they're calling it Fort Eisenhower or Gordon now. I don't know if they're switching back and forth. And I also got, actually I flew in basically from Fort Huachuca, and I'll be going out to Hawaii. So a lot of your commands are getting some of the SANS training. It's excellent to meet all of you, and I feel really privileged to speak here. So thank you very much for allowing me to give back to this community. Okay, so this is our agenda. We're going to talk about, I don't know, who's taken a SANS ICS course? Do you mind? Okay, so it would be a little bit of a review, kind of help you understand, but obviously about 50% of the students, 50% of the attendees need a little bit of an introduction, so I'm not going to belabor it too much, but I'll help you all understand these things. Then I'll get into some example ICS OT deployments because we need to understand the complexity of some of the things that we're trying to protect. And then we'll have a couple slides on outlining some of the current attacks, and I'll get into a summary. So that's going to be our agenda for today. All right, so understanding ICS and OT concepts. The biggest thing that I want you to take away from this talk is that IT and ICS or OT, whatever you want to call it, is different. Now, I use the terms ICS and OT kind of in conjunction with each other. ICS, industrial control systems, OT, operational technologies. Typically, the way I refer to it is at the plant level where you're communicating and connecting to the IT network. That's what I consider the OT assets. ICS assets are usually down at the physical layer, down at the process levels. I don't want to get into the whole Purdue discussions here and stuff like that. However, we need y'all to recognize that there are differences between the IT and the OT environments, which play a direct role when we're considering cybersecurity. First of all, on the left-hand side, we can see the dollar signs. The business units, the IT units, they're concerned about making money, the whole organization. And actually, that's one of the things I like to point out is a business's goal is to make money. IT and OT are a part of the same business, so they have the same goals. Okay. However, IT is usually marketing, they're usually selling and attempting to deliver services and products. And that's what we see on the right-hand side. Our OT is designed to deliver those services and those products. The reason why I kind of picked the icons that we have there, obviously we've got services up at the top, electrical and water. In the middle, we've got some type of distribution trying to get those services and those products, those assets. And the bottom two, the coffee and the automotive, is definitely representing that production. We're producing things that people are going to consume. All of these things work in conjunction, and they have to work so that IT can sell those services and those products. Okay. However, when we're thinking about the different technologies, we can see those two columns there, and we can see some of the differences. I like to point out. Already talked about the data and selling the business processes. Those are certainly an IT thing, whereas operational is there to make sure that they're producing those services and those products. Priorities. I would say, and I like to teach, if any of you have talked to me about the whole, how we're protecting the CIA triad, confidentiality, integrity, and availability. Those are the same in both of these environments. However, the industrial control environments, they would tell you that availability has priority. I don't like to prioritize unless you're putting safety in there, and I definitely added safety in. One of the biggest ones, the life cycle. The differences, IT runs on a 3 to 5 year refresh life cycle just because of advanced technologies, software is being updated, hardware is being updated, and they do like to stay up to date. However, OT operations, the hardware, the software that they're putting in place, they expect that to run for a long time, 15 to 30 years in our example, and sometimes even longer. And that's because it's expensive, and we'll talk about that in the next slide. A few other things, I'm not going to read through all of these, but certainly there are some significant differences that are in there. We need to understand these differences. Your team needs to think about these differences when they're approaching cybersecurity. Because what happens is the IT admins, and let me back up just a second. On the operational side, the OT side, they need help with IT members that understand the technologies that are being implemented and connected to their environment, and connecting that to an Ethernet network that exposes them to the internet. They also need help from the cybersecurity side because threat actors are getting more advanced. They are targeting specifically the OT environments, and our OT teams, they don't have 10 years to spin up on this like the IT. The last 10, 15, 20 years, we've been progressing the IT cybersecurity approach, and the threat actors are using all of their experience over the last 20 years and attacking OT right now. We don't have time for the OT teams to spin up. Okay, so we do need the IT teams, the cybersecurity teams to come in and help the OT teams. However, they need to understand these differences before they start providing recommendations, actually implementing things within these environments, because these differences are based on operational requirements to produce things, not to ensure that we're selling them and have access to data and so forth. So let's continue forward with that. Now, this is what I was talking about with some of our differences, and one of the things that I've been learning about in the last 2 years, which is a big deal in my mind associated with why is the OT side in the state that they are, meaning that we expect these things to last for a long time, and that's because they are very, very complex. It takes a lot of money to get them up and running and ensure that they continue to run for a long lifetime. In other words, organizations are willing to take the risk on purchasing and deploying a lot of equipment. They'll spend those capital expenditure money, those one-time costs, with the anticipation that over time, they're gonna earn that back and more, okay? What they do at the same time when they're deploying it is they consider operational expenses, those things like personnel salary, ongoing maintenance and operations, and it's what they've attributed it to is they've attributed a very specific cost to that, because those costs over time are known to increase and increase significantly. So what they're trying to do is they're trying to manage that operational expenditure, ensure that it stays in line with their initial budgets so that they can keep operating as expected. Okay, and right now, one of the things that I've been hearing about more and more, and Rob Emley, the CEO from Dragos, talked about it in his latest testimony to Congress when they were doing the 15 years after Stuxnet. Okay, 95% of all cybersecurity spend goes to IT, and only 5% goes to OT. And we'll talk about why I think that is a big deal in just a second. But it is absolutely something to consider. We purchase things for these environments, we build them, we deploy them, and we expect them to run for a long time because of their complexity and because of some of the risks that we're accepting as a company. So if we realize that, then we'll move forward. However, think about this. Okay, the things that are in place, I said that we've been expecting these things to last for 15, 30 years. When they anticipated those original costs, when they did spend all of their capital expenditures to get things in place and up and running, and then they calculated out their OpEx, they weren't talking about cybersecurity. So cybersecurity expenditures are new costs, and they're struggling to, first of all, identify funds to do this, to implement these things, and also coordinate it with all of their normal maintenance and their normal expenditures. They weren't expecting to bring on this number of new people, these new technologies. They hadn't anticipated that. And so the reason why it's hard going forward is because they're trying to figure out how to maintain or at least not significantly increase that cost, which might threaten that whole environment, because in some of these organizations, if they can't achieve that within their budgets, then it might be worth it to them to just shut down that process and not run it at all. In other words, they've calculated that risk. Now, hopefully somebody else would build it and pick it up and anticipate those costs. But this is what we're finding in the industry right now, and that's why we have that big disparity. And what it's going to take is leadership understanding that disparity and modifying it, changing it, moving some money over to that operational expenses to improve the situation. Okay? So our organizations that are producing products, whether they're service or actual physical products that people are purchasing, okay? Those companies are designed to sell those services. However, if we're not making them, if we're not generating energy, if we're not generating water, if we're not producing coffee and cars, how can we sell them? Meaning that if those areas shut down, there's nothing to sell. And one of the things that a lot of people don't realize is that shipping is a big deal in all of this. If we can make all the coffee in the world, but if we don't know where to send it, in other words, our business servers go down and we can't say who bought what product, okay? If we also don't know where their addresses are, meaning that we can't print out labels so that those products get on the trucks and are shipped, this is a huge concern, and it actually affects the whole company. So if we can't deliver or if we can't produce, then we can't deliver these things. So what I am arguing here is that the IT, the ICS, the OT, the ICS part of this that helps us produce, this is actually the core of the business. It's not the teams that are selling these things. It's the teams that are producing these things. Now, both teams are required because they have to work in conjunction. However, if you can't produce, like I'm saying here, then there's nothing to sell and nothing to get out there. So I would argue that our control environments are the core of almost any business that's out there, okay? So ICS and OT have different operational requirements than IT. We need to understand that, okay? You'll see in just a second that these environments are designed to produce things. They're not designed for cybersecurity. They're not intended to be connected to the internet. We're connecting them now because of Ethernet, because things are more affordable and within the cloud. And actually, we do get a lot of benefits from cloud services. However, the systems that are actually producing the services and the products within these environments, they're not intended for cybersecurity, and we need to be smarter on how we're approaching protecting these core assets, okay? And we have to definitely consider that risk management within these environments, they do have to feed into our budgetary considerations to make sure that we do have the expenditures that can be delivered for operational expenses within this environment. We have to improve that and increase it. All right. So a few examples, okay? I know ICS and OT are not just PLCs. If you haven't taken some of our classes, one of the first things that I used to think of before all of this is, was just the PLC. The PLC has gotten, I guess, a bad rap around this. So we're going to talk a little bit about a few things. We're obviously not going to go into a lot of detail, but I do want to talk about airport processes to help you understand some of the complexity. We'll discuss some of the manufacturing execution systems, and then I'm going to take it physical a little bit with the liquid natural gas plant. Okay, so one of the things that bothers me is when I'm in an airport and I hear people complaining about the 5% downtime within an airport. Now, I do understand that travel is stressful to some people. However, when you think of the airports operating within the United States and around the world, you should be amazed at the automation and coordination that's going on. All of these core systems that I have listed out, access control, people movers, parking garages, baggage handling, ground support equipment, HVAC, CCTV systems, water treatment systems, okay? These are all systems that are extremely important to an airport and have to be coordinated. If any one of those things go down, it's a bad day at that airport and things start backing up and lots of people start getting really frustrated about this, okay? Not only that, you have to consider the coordination it takes. These are individual systems that are usually run by integrators that are expert in that type of technology, in that field, in the physics of what we're talking about here. They're experts in that. They have to coordinate all of these efforts together. The airport has to have a central control center that's managing all of this, coordinating those. They have to have a radio system or telephony system that can get in contact to ensure all of these operations are running almost 24 hours a day, 7 days a week, 365 days a year. Not quite that because of some of the evening off hours, but even the evening off hours, they've got people there fixing stuff. On top of that, you've got all of the complexity of the airlines. You've got actually got flights. You've got pilots that are coming in and out. You've got their fuel systems, all of the lighting and ground support equipment that are there, moving planes around and getting things in the locations. We're lucky that this actually works together. Human beings are awesome, okay? And so this 5% downtime is just statistically something that's going to actually happen with this amount of complexity. So we need to understand that, and we need to realize that we're protecting all of this. In other words, if threat actors get into these environments, they don't just hack the airport. They don't have to hack just one thing. Really, they might just find an individual thing, taking the water down and denying an airport of water. That's an extremely bad day because now you're affecting all of the people within that environment, affecting HVAC, the HVAC systems, turning the air conditioners off, and how air flows within an airport. That's something that can bring an airport to a standstill as well. So we need to understand that we are protecting at this level of complexity within these environments. And this is just an example of the different types of environments out there. It's not just a single PLC. It's not just something that's connected to the internet. This is a live, active system, okay? So those are airports. This slide, this is actually, I pulled this out from the Aviva website, and this is a picture of their solution, what they call the manufacturing execution system. Now, this system is used in different industries for obviously different purposes. Where I've seen this is in one of my clients that it was a distillery. I went out to Kentucky to help doing security assessments of their actual plants, both their creation and also their bottling plants as well. They use these manufacturing execution systems to manage that distilling process. What these systems are, and the point that I'm trying to make is that this MES, it's made up of multiple servers, running multiple databases, running multiple web applications. Each one of those servers serves a different purpose within that environment. You'll have a data historian, which is collecting all of the data that's associated with millisecond accuracy for everything that's going on with that process. Okay, because we're writing that to the historian, we don't want to do reads because that will slow down the writing process, and therefore we're going to have an object database. We're going to have servers that are managing the view into it, so human-machine interfaces. We'll have the human-machine interfaces reaching into another server within that environment. We've got web object servers and so forth. All of these systems have to work in conjunction with each other to ensure operations of just that system, okay? And that is for one process at one plant, okay? You might have, every plant is going to have a different system. All of these are going to be coordinated. We're not even talking about all of the other systems that are coordinated with this, from HVAC systems to any of our business solutions. None of this runs if we don't have an SAP system in our business environment that is telling us what the business unit actually sold, okay? The recipes for this for our clients, when we actually get recipes, or if somebody has purchased a specialty, in this case, I was talking about the distillery, a specialty mixture of alcohol, then the people that sold that have to get that information down into the control environment so that they can make the products to that spec. What I'm trying to say is there will always be communication and connection and a need to communicate and get that information from the business environment. The business environment actually needs a lot of the information from the data historian and from other servers within this environment. We need to push some of that information out so that they can understand how much we made, so that they can understand the quality of certain products, so that they can sell that as well. So there's always going to be this interaction, this exchange of details from our corporate buyer environment into our control environment. On top of that, we're going to have third-party integrators that are integrating and providing us with services for some of these things because we can't keep the people on staff that understand some of the physics, okay? So manufacturing execution systems are just an example of some of the complex systems that are required to produce some of these products that are out there that are expensive and difficult to understand and to implement. I keep trying to remind everybody that this is designed to manage a process. It's not designed for cybersecurity, okay? We don't want it doing cybersecurity. Do we want to configure the servers correctly? Absolutely we do. And that's why we need IT people to come over and assist the OT environment. But one of the things that I say about that is we need the OT admins to be in charge of that hardening, because they have operational requirements. All of these servers have to work in conjunction together. When cybersecurity teams come in and they say, oh, I think we've detected malware on this system, we need to take it offline. If you take one of these servers offline, the whole thing goes down. So our incident response is actually going to be different as well. We need to understand that these are fragile systems that have to be maintained carefully so that they can operate as expected. A little bit of downtime means a lot of missed product being developed, which means that we're not able to sell it, which actually feeds into that cost, and that cost is taking away from those operational expenditures that we were talking about earlier. All right, so we can't afford downtime in these areas. Okay. Liquid natural gas. And so liquid natural gas, gas and oil, the reason why I have this slide is I wanted to help you remember that this is physical. It's not just a computer system that's in a data center, okay? The picture that we have there, that is the Cheniere liquid natural gas production location. It's Corpus Christi, right outside of where I'm at, where I live. Okay, they've got, you can see at the lower part of that image, you see all of those different, they look like little blocks that are about the same size. Those are huge. They call them trains. They're actually liquefying natural gas. Natural gas is going through all of those pipes. They are being compressed and condensed so that they actually go down and liquefy, and now they can put it in storage vats to send it off. Okay, and vice versa. When they come in, then they have to deliquefy it so that they can send it downstream in the pipes. They actually refer to those as trains. Okay, so the system that I have, you know, and I just made up this example from some of my experiences dealing with some of the gas and oil and liquid natural gas clients that I work with. We can see at the top, and I know you can't read it. I know it's an eye chart, but just kind of deal with me here. At the very top, we have our IT environment. Our IT environment that has a firewall that's going in and allowing access communication down into our control environment. We have a DMZ in the middle there between the two firewalls that you see there. The bottom firewall off to the right-hand side, that's our plant network. We actually see some of the supporting equipment in there. And also a lab environment, which is one of the things I was introduced to last year. Some of the lab environments, while they're not used for production, they actually are required in a lot of organizations because they need to understand the quality of the product that they're producing. What is more surprising is that down below we've got two different areas that are actually at the process level, which are actually the physical implementation that you see in the image to the left. In that example, I actually have two different vendors, meaning that the environment on the left is an Allen Bradley implementation. Their distributed control system is implemented within that environment. They do have multiple servers that are controlling that whole environment. Those systems, those servers are actually deployed by Allen Bradley teams, integrators that come in. The owners and operators of this, they don't really have any effect on those systems. The integrators deploy that. They configure them to the owners and operators requirements sometimes. Usually they're just following Allen Bradley's normal implementation of that environment. On the right-hand side of the image down, the network diagram down below, we have a completely other process. Okay, and that one's actually a Delta V process, another distributed control system. Delta Vs are, I can't remember, I think it's an Emerson product, okay, implemented by another team. And there are many plants that actually have multiple processes within their environments, each one deployed associated with a different vendor, different integrator team, which means that they have different operational agreements, different implementation of the servers and configuration, different users in place, and so forth. Okay, that can be for any number of reasons. That implementation of two different products. It could be that they were the cheaper. Emerson was the cheaper bid at that time when they went with the new system. The whole organization that was working there could have the CEO could have changed hands, and they preferred Emerson over Allen Bradley. Okay, it really depends, and we don't know. Understanding the history of how some of these things got implemented, that is really important to understand how we're going to protect things and give some operational requirements. When we're thinking about Active Directory at the level 3 environment, so the whole plant, that is usually managed by the owners and operators. Okay, and depending on the organization, whether or not they have force and trust down into their process level, it really depends, and that's the challenge. That these really complex physical systems are managed by so many different people with different operating requirements and different techniques for doing the same type of process, with different types of technologies being implemented and checking on all of that. Okay, when we're thinking about ensuring that this runs. This has to run within this environment. They can't shut down. If they get shut down because of an attack, something is seriously wrong and they are hemorrhaging money. And a lot of times when threat actors get into some of these environments, they actually, as long as there's not a safety risk, and safety trumps everything, they choose to operate, trying to figure out how to island the appropriate environment so that they can do operations. One of my favorite things last year was going to a gas and oil team, and we're doing I like to do physical walkthroughs so that I understand the actual process, and I know what they're trying to do, but I also get to see their physical security protections. I get to understand their standard operating procedures. I get to liaison with the actual operators as well, so that they know I'm there to help and that I'm going to be considering their process before I even start making recommendations. I like to walk through that, and whether it's out on the field where I can't, they don't take me. But I remember going into a data center, and as soon as we walked into the data center, he walked right up to his cabinet and he pulled out a laminated sheet of paper. And he was like, see? I was like, what is that? I didn't know what that was. And it was their islanding procedure. In other words, they had ransomware in their corporate environment, and they had to disconnect, but they never had that process written out. And after that traumatic ransomware, IT ransomware experience, they weren't going to do that again. And they actually had every step that was required to disconnect from the control or from the corporate environment and run the system manually. And these are some of the types of things that we want to see within these environments. Manual operations are fine. Now, we do need information from the business unit. More than likely, we're going to have people on site so that they can do certain things. But this is a physical environment that needs to run. We need to have operating procedures to step through that and allow that to occur. And we have to practice those things. So gas and oil, in all of these systems, I'm pointing out liquid natural gas and gas and oil here, but just about every control environment is like this. Very complex. We don't know how it was built. Sometimes there's different vendors and integrators, so we'll have multiple different solutions that are in there. Some of our areas, even though we own a plant, we don't actually run the process. We've hired somebody else to do it. And so their operation techniques, hopefully they're adhering to some of our requirements, but certainly they're following their own processes, okay? So we need to understand that if we're going to secure it, if we're going to do this better. Okay, so like I was saying, operations can be very, very complex, all right? They require a lot of coordination between the owners and operators, the vendors and integrators. They're not just single solutions that are out there. It's not just a gas and oil plant. It's not just a liquid natural gas plant. There's a lot of physical things that are implemented. There is a lot of other coordination with other assets. One of the things I didn't bring up, okay, what is that liquid natural gas plant required to run? There's two things that it probably requires to run. Anybody? Power. It needs power, okay? If the grid goes down, what happens? Do we really want everything shutting down? Do we really want that liquid natural gas warming up? Okay, especially in Corpus Christi, we've got humidity, we've got heat as well, and the temperatures are just going up. Okay, so that means they have their own generation and they probably have their own switching station. They are liquid natural gas professionals. So who implemented their actual substations? Okay, and when we start thinking about mission and we start thinking about other locations that are connected to the grid but might have to supply their own power, okay, maybe we need to start asking the questions about how that substation is implemented, who has remote access, and so forth. They also require typically water. Okay, so some type of water filtration or some other system on that environment, and those are the same types of systems. When the water and the power go down, processes tend to come to a stop. When HVAC goes down, sometimes we can't have those people in those locations because of a safety requirement. We have to consider some of these things. All right, very complex environment, very integrated with other processes, and this is the level we have to defend at, okay? We can't just defend individual processes. We have to consider all of the other components that are playing a role in ensuring that those operation or those, whether it's services we're producing or products that we're producing, that we're doing what we expect, okay? It also means that very last one, that last bullet, these technologies focus on complex physical-based decision-making, not on cybersecurity. Cybersecurity is just support. We are supporting to ensure operations, okay? The operations have priority. So as impressed as we are with our cybersecurity knowledge and going forward in the importance, we all understand that it's important. However, operations takes precedence. We have to figure out a way to protect it and ensure not to put on requirements that are associated with our own typical IT knowledge, okay? All right, we're going good. So, outlining ICS and OT attacks. Let's talk about some of the most recent attacks and some of the concepts that I'm concerned about as we're going forward, okay? So first of all, one of the things that I did is I pulled in a lot of research from 2003 and 2024, and I'm actually using a Notebook LM. I'm not sure if you're familiar with Notebook LM from an AI large language model perspective, but you can pull in a lot of reports and you can ask it for some specifics around what's in those reports, some correlations between reports from Dragos and Nozomi and Verizon and CrowdStrike and so forth. And it's really helpful in understanding some of the correlations, the differences in what they're seeing, but also with understanding the consistencies across the different organizations because they all have their expertise. Now, one of the things that came up, and as I was reviewing the Nozomi, they had this image that has their top 10 techniques that they were detecting when they're gathering information. So the cool thing about organizations like this is that they can collect information from the owners and operators that they are partnered with, and then they can start correlating some of those common things that are happening across different industries and different industrial sectors. The top one there, it's an eye chart, I understand that. But the top one there is about data manipulation. So data manipulation. Now, in the report, they didn't get very clear about what that could mean. It could mean that some operational information was obscured. It could mean that threat actors were actually getting in and changing logs. What I think is most likely is that we've seen a significant increase in ransomware within our control environments last year. If you didn't read the Dragos report, they call that out very specifically. So what I'm thinking is that Nozomi is seeing some of that data manipulation associated with the ransomware that's getting in those environments because it is increasing. It is a focus, okay? And that could be a cyber criminal focus, getting the ransomware in there. But when we're talking about denial of service, there's no better way to do denial of service than take out backups, take out Active Directory, and encrypt everything. All right, so that we're seeing this more and more for different reasons that are out there. Another thing, the next two down on that list, they're talking about the command and control mechanisms that are being used. They're seeing those activities. Now, you would think that our control environments are separated from the internet. However, they're not separated. They are connected to an Ethernet network, which is connected to our business network and sometimes connected to the cloud. A lot of vendors are turning to cloud solutions. A lot of owners and operators are leveraging their cloud teams to improve their services and improve their access down at the process level, okay? Which means that threat actors are looking to how they're doing those communications. It allows data in and out. So we're seeing this for C2, Nozomi, and the other organizations. We're seeing that they're turning to the normal C2 protocols that we're used to. We're used to seeing those, but they're also turning to some of those protocols that are leveraged within control environments, okay? Industrial control protocols that are going across these boundaries and out. Now, we don't typically see the operational the mod buses and the OPCs and the Profi nets going outbound. However, we do see the protocols that are exchanging information, the publisher subscriber that is providing information to some of our HMIs and our other data collections. And so one of the more recent C2s that are based on our control environments is the MQTT protocol, and you'll see that was implemented in one of the attacks we're talking about here. So we do have to consider how we're doing those connectivities, exchanging information, whether it's from our control environments to the owners and operators cloud infrastructure, But in my mind, we should be more worried about those going out to our vendors and integrators, those services that they're providing, because they control those assets, and we have to manage and monitor that very closely. We need to do it with both, but definitely third party when we don't have the control over those assets. We don't, asking somebody for logs from their cloud service, you can ask, but you're probably not going to get it, right? So that's why it's a little bit better when we're actually implementing it as owners and operators. Those cloud services are themselves prefer that. Now, the denial of service impact, one of the things that I found interesting reading the SANS 2024 survey. So the SANS ICS team actually puts a survey out every 2 years, I think it is now. Might be every year. But we put out a survey to see what they're actually experiencing within their environments. And this stood out to me, especially when we're talking about ransomware and the impact. Okay, it highlighted that 38% of the ICS and OT ransomware incidents impacted safety and reliability of the physical process. So this means that when we get ransomware within these environments and it starts going through those servers that we're talking about, the MES servers and the other servers that are supporting liquid natural gas and gas and oil and so forth, okay, those are used for operations of the physical environment. And so the fact that those services are going online, now there's nothing managing those chemical reactions, which means that those people on those sites are now scrambling to try to take control of these situations to ensure that they don't have the catastrophic effect that is happening. Now, ransomware, of course, it's the cyber criminal. The cyber criminal doesn't want anything blowing up because they want people to pay money to them. However, this is the side effect that they don't understand within these environments because they're IT attackers, I guess. Certainly, this is why we need to consider this as a threat to some of our organizations. All threat actor groups are going to understand that. So let's talk about some of the different campaigns that we experienced in the last years. So I'm not sure if you're familiar with the Bauxite threat actor group. That's Dragos' name for this group. In the Dragos report, they actually outlined the IO control campaign and in pretty good detail. Now, this was a two-stage attack that we're going at. It was specifically targeting some of the some internet-connected systems. The threat actors were actually going after fuel management systems in the United States and Israel. Okay. They identified through research on the internet, through scanning, through Shodan, through other techniques, they identified ICS assets and actual devices that were connected to the internet. They attacked those. They had actual malware that would run on the devices, and some of the devices supporting systems, they uploaded that. Okay. It established a C2 communications over MQTT. And how I was reading it is that the reason why it was they were able to do that is that they did have, these devices did allow MQTT exchange of information up to the cloud, which is normal. Okay. However, it was what I think happened is the firewall rules that were associated with that normal traffic were not targeting the endpoints. The firewall rules were probably targeting the CloudFront infrastructure for that. And so the MQTT C2 communications that the threat actors were using was hosted in CloudFront. And since they didn't have the rules locked down specifically, that allowed the C2 communications from the control environment outbound. This malware also contained the burn it all to the ground aspect, meaning that it had a wiper in it as well to have an effect on its endpoints and devices, which causes denial of service and within these environments. Now, certainly, this is targeted very specifically. However, this is something that we need to take into consideration. They weren't going after a very specific target. They were targeting the type of assets and environments that were associated with the fuel management systems. In other words, they looked for as many targets as they could find. They weren't just targeting a specific organization. And they looked for things that we don't normally consider and think of. They looked for things that were not necessarily the core of the business. They looked for those outlier parts of the process that they could attack, which would have a cascading effect within that organization. And that's what we're defending against when we're talking about some of these environments. Now, the Frosty Goop attack, another one that was outlined in the Dragos report. I had a friend of mine, she actually worked on some of the analysis of that. She was really excited when this report went out. Okay, and it was obvious afterwards. They did a lot of really good work in researching this. So this was another device that was facing the internet. This was they actually went after, the first part of the attack was I don't even know how to say it, Tiki routers, which are the routers that are exposed to the internet and allowing remote access to these environments. Now, this was specifically designed, this attack was specifically targeting, it was a Russian-based group, and they were targeting the municipal district heating systems in Ukraine, okay? Once they were able to use that 0-day to exploit those routers, they gave them access to that environment. They uploaded a C2, the regeorge web shell, which is obviously more than likely using HTTP and HTTPS traffic. Okay, they uploaded those web shells to the management systems within those within that community, which allowed them to have that remote access. They went into the controllers that were the encode controllers, which were controlling the heating distribution systems. They actually downgraded the controllers to an earlier firmware. They weren't sure in the report, and talking to some of the people that I know that were researching this, that didn't give them any capabilities. But in my mind, if I'm thinking about doing security research, I'd probably want to, if I did all of my research on a previous version than what's implemented, I'd want to make sure it works by downgrading it. So they downgraded the firmware. They then send Modbus commands to the controller to change its configuration, and it caused faulty readings, which affected the implementation of heat within these communities. Okay, so specifically targeting those outlying systems, in this case actually targeting the businesses and public aspects of people in Ukraine. Okay, the Modbus component of that, though, and this is something that we're seeing more and more in, and actually SANS, I think one of the things that the SANS ICS team is considering is a malware, ICS malware reversing class. And that's because we're seeing more and more of malware actually implementing industrial control protocols. This malware could have, while it targeted specifically those encode controllers, could have targeted anything that was doing Modbus. Okay, so in other words, we're going to see this framework being shifted and used in other attacks. Okay. Something that came out when I was doing my research and kind of trying to understand some of the consistencies across the different reports that were put out there last year and in 2003 is the fact that we've seen a significant increase in threat actors targeting remote access systems. And actually, my understanding is that this is the first time we've seen a decrease in threat actors actually leveraging phishing to get as their initial infection vector or initial compromise vector. They are actually did this more in the past 2 years than phishing campaigns, or at least this was more effective for them. So the first one is the Verizon DBIR report, the database on incident response. And in their report, they saw a 34% increase of targeting those endpoint devices, in other words, those edge devices, VPNs and so forth, with 0-day vulnerabilities. This was provide them access. On the right-hand side there, we see the M-Trends report from 2024, so that's the one that's put out by the Google Cloud team. And in their report, when they helped people respond, they noticed that had a significant increase in the exploited vulnerabilities that affected security devices on the edge of the network. Okay, and they did also notice that those successful campaigns that they did incident response for were also leveraging 0-day exploits on the edge. In other words, your threat actors are looking at your exposed infrastructure. They are practicing and weaponizing their attacks, okay? And they're being effective at this. They are doing their security research on those edge devices, whether they're firewalls, whether they're routers, whether they're your cloud infrastructure. They understand it, They're going after it because they realize that it allows them access directly into your control environments. They don't have to do that stage one anymore, that attack on IT environment. They'll still do it. I'm not saying that they're going to turn away from it. However, they're more effective and more successful when they can get direct access into your OT environments because of these edge endpoints. They realize we have to have remote access. We have to be sharing data with our vendors, our integrators, and even our own teams and our cloud infrastructure. Okay? The only way around this is through monitoring and understanding your access. I talk to a lot of organizations, and when we talk about their edge devices, their VPNs, I was like, who can tell you who logged in for the last 5 times? And it gets quiet in the room. I've had a few people say okay, and say who it was, but most organizations, they can't tell you. In other words, they're not monitoring those edges. They don't know who it is. I usually get told, oh, that information is going to the SOC. Well, who does the SOC call? The SOC doesn't know who is supposed to log in or anything like that. The people that are responsible, the teams that are responsible for those OT environments, they need to be involved in that monitoring and actually detecting unauthorized access, and more importantly, the authenticated unauthorized access. They need to be reviewing those as well. All right, so just a quick summary, okay? First of all, if you haven't read this article, I would recommend that you go out and read it. This just came out last week by Ann Newberg, and she writes about the differences between the United States, North America, and China. It is a very good, I think, viewpoint on why China's being successful now, how it's difficult for us to actually go after some of their infrastructure. And she talks about the disparities and the differences in our full society, the United States full society implementation of this, how our leadership needs to change the approach to cybersecurity within these environments. Now, she does go into some higher level, talking about using AI with all of the data we're collecting, talking about using digital twins. I do agree with the digital twins. AI, I do believe in leveraging AI to correlate a lot of information. However, I need to remind all of you and everybody else that it takes people with people minds to defend this infrastructure and prevent attacks and actually recover, okay? Because the thing that we're talking about here is that we're responsible for defending these things, but we're also responsible for recovering effectively so that recovery ensures we're producing the services and the products, okay? And the threat actors don't come back. Now, AI should help our teams, but it's not going to replace our teams. Hopefully, it's just a force multiplier. We can't get rid of force. We actually have to increase it. It's that operational cost we're talking about. Now, I do believe, and one of the people that I listen to, Dale Peterson of Digital Bonds, he kind of brought up in an offhand comment that it doesn't seem like she's really considering how well our people defend these environments. And I think Dale is right. I mean, every organization that I go into, those people that are operating things are dedicated. They are there to ensure operations. It's not just because they think it's important. They know it's important, okay? And they're proud of those environments, and they know how significant it is to the operations of that company, but also to their communities, okay? I also feel that we need to simplify this. We need to simplify this approach because we're trying to force IT risk management on our OT environments. Okay, IT risk management, I understand our IT environments, we're connected to the internet, we're connected to the cloud. We've got all of this new and exciting, federated authentication, and we're moving towards zero trust, and I think it's kind of cool. However, that is all IT concepts. Okay, we're not moving in that direction, I think, anytime soon within our control environments. I hope we get there. However, we need to defend right now. Like the other side was titled, we need to get good right now. And what that means is defending these environments, ensuring that they're operational when we expect them to be operational. We need to scale back, okay, and think about how we're defending, okay? One of the things that we put out in SANS is the SANS 5 ICS cybersecurity critical controls, and you can see them there, okay? Incident response. We do need to have an incident response plan. However, I think it's more important, in some of the things that Tim and Rob talk about around this, is that we need to understand what assets we need to defend, okay? And so we need to identify those critical assets, and in my viewpoint, we need to identify remote access into those environments, because that is the avenue approach to get data in. Also, whenever I'm doing my security assessments and making my recommendations, I focus first on secure remote access. First of all, because we've already identified the threat actors are specifically targeting those assets. Also, as a security researcher in figuring out vulnerabilities, exploiting those vulnerabilities within these environments, you cannot exploit a vulnerability if you can't put packets on the wire. You can, okay? If you completely disconnect that from the internet, and there's no way for me to send a shell to it or some other command to it, I can't do anything. There's no way I'm going to exploit it unless I can get physical access to that environment. So ensuring you're reviewing your secure remote access and ensuring that is what you expect, and those communications are what you expect, I think that is your first starting point. And then, of course, going through defensible architecture, monitoring. We do not do enough monitoring, and that's why it's on here. And then, of course, looking at the attack surface as well. Okay? So we've got 5 minutes. Do we have any questions? Yes, sir. Sitting down. So while I understand the question, I think it's the wrong focus, meaning that architecture is what we need to be focusing on. Threat actors are like water, and security researchers we're like water. We look at inputs and outputs. We determine the vulnerabilities in that, and whatever it takes to communicate with that, I'm going to use those protocols. So I think it's. I don't think one protocol is more vulnerable than the other. Every vendor implements those technologies slightly different. Some of them are going to do it well, and some of them are going to do it bad. So I would protect at the architecture level, understanding the baseline of those communications. I would focus on that, understanding what is normally being done, so that you can detect when something unusual happens when an exploit is being sent. Does that make sense? Yes, we have to assume that we're going to be compromised, okay? However, what you want me to do is help you predict what they're going to use, the tools and the techniques that they're going to use. And you just said it yourself. They're going to use whatever they can. So I would rather not focus on the vulnerabilities within a specific protocol or a specific device, right? Because what are you going to do? You're going to take that off? If you're going to take that process off, you're actually applying the IT mindset of removing something when it's actually operationally required, okay? So I would prefer that you step back, okay? Understand that those operations are supposed to occur, understand what is normal within that environment, work with your OT to understand some of the one-offs, okay? And then help detect when something unusual occurs. And I hope that helps. Somebody else had a question. Yes, sir. Yes. So to answer your question about the studies and so forth, that's what some of our governmental cybersecurity organizations, CISA, Department of Homeland Security, if it's specifically related to airports, I would imagine that possibly there's some other entities as well. I don't know of any specific reports. I would look to CISA and some of the other things. To me, some of that information would be classified and it wouldn't be on any of the feeds that I'm getting. However, you know, it's obviously CISA needs to be and is being refocused a little bit around that. I do think states have more of a role to play in doing this, meaning that it's that their environments are in implementations and even state requirements are different, you know, and because of their different locations. Where I would look to is they've got the information sharing centers. I'm not sure if those are still funded anymore, but those were the organizations that were being designed to collect that information, to analyze some of the situations, detect the indicators of compromise, and release that to the specific community. So I would have looked there for that type of data. One of the there's another point I wanted to make. Is that you brought up about you know, some of the storms and some of the other things that happen. If you're not aware of it, and there are studies out there for this, I'm not sure specifics, though I can't point to the specific ones. However, threat actors used to identify when storms hit a specific area, and then they started attacking them. Well, they've gotten smarter, and now they watch the news, they watch what the weather and other conditions are in certain areas, and they're starting their attacks before the actual weather events happen. Right, so we are seeing that trend, and I've talked to several people. I don't know where it's published, but I've talked to several people in the industry. So I'd look at the ISACs. I'd start looking at the states more, and hopefully CISA can continue giving some of that correlated information across the United States. But you know, it's difficult to get that information if you're not in the know or in that industry, because they do keep it close. Does that answer your question, sir? Okay. Anybody else? Yes, sir.
In your last slide, you mentioned don't force IT cybersecurity onto OT environments. I take that as IT practices should be tailored for OT, but I guess what are some of the ways that that can go wrong?
So that's not what I meant. IT practices can't be tailored towards that. Actually, my favorite implementation is the gas and oil teams that I've seen. Now, I do think that IT experience needs to come into the OT environment. I think that everything needs to be led by the OT, meaning that I have a client, and when I went up there and to do some of my security assessments of their changes that they'd implemented, they actually had an OT cybersecurity liaison with us. They actually led it. They actually saved some of the plants. We were going to do a few things for information gathering that would have tripped the plant, and fortunately they stepped up and they started talking about it. So now the technologies are the same, but they're implemented differently with different purposes and different operational requirements. So this is exactly what I'm trying to help the IT cybersecurity teams understand, the IT admins that are coming to help. This is not the OT environment. You shouldn't be taking how you do things out there. Some of the techniques are going to relate. However, you need to take an operational approach to all of this and turn to the team members, and the team members that understand operations should be leading all of these efforts. They should be getting input from the IT teams. However, they need to get used to being told, no, we can't do that. Find a different solution. To me, that's just opportunity for you to act smarter. I don't know if that answers your question. Okay. Anybody else? We're a little over. I don't know if there's another. Is there another talk right after this? It's at 2:30. Okay. We got anybody else? All right. That's it. Thank you very much, everybody. I really appreciate the opportunity for giving back. Take care, everybody. Oh, and here's information about 613. We are, like I said, CDI in December 12th to 16th. It's in person only, just because we haven't got it on demand yet. That's probably not going to come until 2027, and we will get a certification for it, but we've got to work with GAC to get that in place. So it'll be probably a year as well. I'm not the guy to talk to about that. Excellent.